Classifying acids and bases, Lewis acids and bases. We're going to change it up again. In the early 1920s, G.N. Lewis offered the most general model for acid-base behavior. He proposed that a Lewis acid is an electron pair acceptor, while a Lewis base is an electron pair donor. The value of this model is that it covers many reactions that are not covered by the Bronsted-Lowry model, which of course covered many reactions that were not covered by the Arrhenius model. So we're getting better here. An example is that some metal salts are acidic in aqueous solutions despite not containing a hydrogen atom, which of course was the Bronsted-Lowry model. An example of this is a 0.1 molar solution of zinc chloride, which has a pH of 5.4. We didn't cover pH yet, but we will later on in this unit, but that means it's an acid. It's less than 7. In the Lewis model, this is explained by the hydration of zinc. Here, the zinc 2+ ion, right over there, accepts 6 electron pairs from oxygen atoms of water. These water molecules are acting as bases. The zinc ion, in contrast, is accepting electron pairs into unfilled orbitals. Therefore, it is acting like an acid. And notice how this was drawn. We've got all the oxygens connected up to the zinc. So this OH2 looks a little funny, but we're just trying to show the oxygen bonds there. So we have a complex ion formed with a zinc ion and 6 water molecules. How does this explain the acidity of a zinc chloride solution? Well, we have the positive charge on the zinc, right, the 2+ over here. It's able to stabilize the negative charge. In fact, for one of the water molecules, let's just circle over here, it makes it easier for it to lose an H+ ion. The negative charge on the OH- is stabilized by the +2 positive charge of the zinc ion. That explains the increased acidity of zinc ion containing solutions. Let's show another example where the Bronsted-Lowry model falls short. We're going to take the reaction between boron trifluoride and trimethylamine, and that only happens in the gas phase. Boron trifluoride has 6 valence electrons, 2, 4, 6. It can complete its octet and become more stable by accepting a lone pair of electrons from the trimethylamine. Therefore, your boron trifluoride is an electron pair acceptor, which makes it a Lewis acid, and the trimethylamine is an electron pair donor, so that means it's a Lewis base. Summarizing, a Lewis acid is an electron pair acceptor. Metal ions with unfilled orbitals or molecules with incomplete octets, such as boron trifluoride, are good examples of Lewis acids. A Lewis base is an electron pair donor. Molecules with lone pairs of electrons, here's some examples, here's water again, are good examples of Lewis bases.